Okay, my name is Robert Ramey. I'm a Boost library author, and the title of my talk today is Writing Effective Documentation for C++ Libraries. I'm pleased to see as many people here as I see. It's a topic that nobody really wants to address. There's a good reason for that. It's, let's see, it's a pain to write. It's unpleasant to write. It's a task that nobody wants to do. It takes a lot of time. It's time consuming. It's not appreciated. And the worst part is, that's the worst part, that nobody's happy with it. A recent survey on GitHub concluded that 93% of people reported being frustrated with, quote, incomplete or confusing documentation. To me, that's an incredible number. It means that a huge number of people are investing a huge amount of work that a lot of people don't think is very helpful. Now, the upside of this is you can do a really bad job at it and you won't get fired. I mean, that's the proof. But the main thing and the thrust of my talk today is that I think that this problem holds back our development. It keeps us from making better stuff. And so not only is it unpleasant, it's counterproductive. And what we want is documentation which is easier to write, it's less tedious, less time consuming, all the stuff that it actually is. We want the 180 degrees different from that. We want it helpful to users and helpful to other developers. I think that's, I don't think there's any disagreement about that. So the question is, how do we fix this? As programmers, to a man with a hammer in his hand, the whole world looks like a nail. To us, immediately we say, you know what we really need is a better tool that writes the documentation for us. And we have tools. And there's always disputes about the tools. And there's always, in the tool thing, there's always more hype and all this. The fact is, we still got the 93% of people who are saying the documentation isn't working for them, in spite of the tools we have. Better tools are not going to help us. We have to step back and think, wait a minute, it's not the tools, it's something else. The tools do have something going for us. They do create, oftentimes, very nice looking documentation. And a lot of times, it saves a lot of work because one particular favorite tool, and probably others, glean information from looking at the header files or the function prototypes or whatever, and then take that information and present it in a way that looks like documentation. It's seductive, it's attractive, users don't find it particularly helpful, and why not? Well, it doesn't really add any information which is not in the headers already. So if we do it if we go down that route, we're going to find that we're going to be producing good-looking documentation which still suffers from all the problems and disappointments that we already have. So here's how we go about doing something. We get a task from somebody, either a boss or team leader, or we make it up ourselves or whatever, and we start to code because that's what we like to do. And we'll go through a couple prototypes and try this, or we'll look for libraries, and we'll do what we do. When we got something that we think looks like it might work, then we'll write a test. Well, maybe we'll write a test because a lot of times we don't, because that's another tedious job. But oftentimes, we might write a small example. Just for one reason, at least on the IDE I use, I can't compile a header file without a CPP file. So it actually forces me to make a little CPP file at least with an include and a main in it. But oftentimes, even before drinking the Kool-Aid here, I would be inclined to make a small test to see if the thing does what I think it does. It never works the first time, or rarely works the first time. So this little test or a little example really ratifies what I'm trying to do. And so, and after we go back and forth on this for quite a while, then we'll start in writing a documentation. And when we do that, we're kind of amazed and disappointed. Of course, now we've already told the boss, wherever it's done, all I got to do is just write up a little document. And he says, great, here's the next job. Start tomorrow because you can do the doc today. And then we discover when we try and write the documentation, it's really hard because we can't really describe exactly the way what we did. And or it starts out well, and then we get to a spot and then, well, wait a minute, you call this function, but the output depends on something else over here, which is set by another function or depends on this type. Oh, actually I have to include that information too, otherwise the person who uses this thing won't be able to know under what circumstances this call is going to give what answer. And of course, if you step back just a second, you're thinking, actually, we should make some changes in the code. How many people have come across that situation? Okay, that's fine. We've all done it because it's impossible to avoid. When you're writing code, you're not really thinking about, you've gone below the original abstraction. Now you're into the code. At that point, when you break the abstraction or the original abstraction isn't correct, now you don't see it until your code is done. So it's too late to fix the stuff. You already told people it's done. You already put it out there for people to try. And now you're in a box. You either have to take on more work or just sign it off. And what are we going to do? We know what we're going to do. We're going to sign it off because we got other stuff to do. And then, of course, we end up in that 97% because that's, but as I say, good part is we keep our job and we get a raise because we got it done. And because nobody really actually verifies whether the user's really happy with it. If I sound cynical, well, that's actually true. Anyway, so I'm going to, now I'm going to give some positive, constructive, and useful advice. I think I put my finger on what the problem is. Now, how do we get around that? The thrust of this idea is we write the documentation in parallel to when we're writing the code. This has a couple great benefits. One is it stretches out the job in little pieces. So it's not faced with the job, we got a week to sit down and look out the window and stare at this stuff and then type some more and then become frustrated. No, we just do it in little bits. It's much more than that, but if it were only that, it would still be quite helpful. So we're gonna write the first sentence of this document. It's just one sentence. Sure, if we've been given a task, we can sit down and write one sentence what this module or what this function or what this type or is going to do. That should be pretty simple. So that's what I recommend doing. Writing one sentence, maybe two. I think most of the time it can be done within. You go back and take it to the boss. Okay, you're signing off on this. This is what we want. Or your team leader or all the other people that are going to use this thing. And they'll say, yeah, sure. Well, you'd be surprised how many times they don't say that. You'd be surprised how many times I'm talking with somebody else and we have a totally different idea of what this thing is supposed to do. Just writing this one sentence and coming to agreement on it is a huge step. Now here's a couple examples. This is just fun here. Here's an example from a library that was proposed for Boost a year ago or whatever. I'm going to read a little bit of it just so you can cringe. XXX is a C++ library which lets you schedule an order dependency graph of file input-output operations to be executed asynchronously to the maximum capacity of your hardware if you want to do portable asynchronous I/O in C++, especially if you need to easily consider or order issues of reads and writes. This is the correct library to be using, yada, yada, yada. Okay, I mean, right away, if I'm reading that, I'm done. if I'm looking and I have to go through 20 pages of this, I'm finished. And so that's an easy one because, as I say, I'm done. And I'm going to give an example of, I did take the time to read this. It was kind of painful, and it was kind of time consuming. And I said, if this gentleman had written the following, I think that we would have been off in a much better place. Now, it turned out that that library wasn't accepted into Boost, in large part, I think, because of the previous page was symptomatic of the whole thing. Nobody could really feel confident they knew what it was supposed to do. So that's a pretty easy one. But now let's look at some libraries that have been accepted into Boost. Now we're going to switch the thing around, and this is just for fun. I could skip this part, but it's too much fun to skip. So I picked a number of libraries from the Boost library set, and I just picked the first sentence or first paragraph from the library documentation. And I'm going to state it here, and I'm going to ask you guys to guess which library you think it might be. So this library provides, yeah, what is this, Jeopardy? I guess this would be Library Jeopardy, wouldn't it? The C++ library provides functions, classes, templates, traits, and macros for the control, inspection, and diagnostic of memory alignment. Who has a guess? This is the easiest one. Come. This gentleman, you have to have a guess here. You have no idea. Okay. I'm disappointed. But I'm going to help you out, at least with the first one. Boost Align. It seems obvious in retrospect, huh? And actually, this particular sentence, I think, is actually an exception to my case. I think this is actually a very good summary and description of what Boost Align does. So this guy, who's the author on this? Huh? Normally, I'm not going to name names. Glenn Fernandez. Huh? He's been in Boost for quite a while. I think he did a great job with that. And though I don't know for a fact, but just reading that suggests to me that it's going to be smooth sailing if I start to use this library. Yes?
Yeah, the question, how is enumerating functions, classes, templates, traits, and macros? That's like every C++ library provides that. Why you should enumerate this in the first sentence?
Well, that's an interesting question. What you're telling me is this is understandable, but actually could have made it shorter, right? He could have said this C++ library provides facilities for the control, inspection, and diagnostic memory alignment. Would have been an improvement. Yes. Even a good one get improved. This is actually better than like 98%. But even then, you could still do it better. And you're right, it would have made an improvement. It's good enough as it is, but you're right, it would have made an improvement. Okay, now we're warming up. Let's see if we can get somebody to stick their hand up this time. There are times when a generic, in the sense of general opposed to template-based programming type, is needed. Variables which are truly variable, accommodating values of many other more specific types, rather than C++'s normal strict and static types. We can distinguish these basic types of the generic type. Well, the only thing that's missing here is iambic pentameter. So, let's have a look. This gentleman suggests Boost Any. Well, Boost Any is one. Any Hana? Variant? Okay, how many are going to vote for Boost Any? All right. Oh, I ruined it. Boost Any. Okay, this, frankly, you're very astute. Have you used Boost Any? Okay, well, I'm very impressed because that particular introduction was totally opaque to me, I have to say. But now listen to this. This is the gentleman who wrote this, Kevlin Henney, is a very well-known author. And for whatever reason, when he got into, and very successful and a great speaker. So when your own stuff looks like this, you don't have to feel that bad. because it's apparently hard to avoid. Okay. All right. I just have 2 of these to go. And I would have done less, but it's so much fun. The standard template library of the C++ standard provides a framework for processing algorithms on a different kind of containers. However, ordinary arrays don't provide the interface of STL containers, although they provide iterator interface to STL containers. As a replacement for ordinary arrays, STL provides std vector. However, std vector provides semantic for dynamic arrays, thus it manages data to be able to change the number of elements, etc., etc. Okay, this gentleman.
Array.
Array. How many people agree with array? Okay. Anybody have any other bids? Container. Anybody buy onto container? Okay, array's carrying the day. And let's see what it is. It's array. Okay. Yeah, well, I said, wait a minute here. That's a very interesting question. I said, I'm just going to pick off some random Boost libraries. And what did? I just looked at the list and picked the top X number. So I was in a hurry, and I just said, well, let's just start looking. Oh, and just the first group turned out to be a good sample. So I ruined it at that, and I just can't get anything over on this audience. It's very stressful giving a talk at an environment like this, I have to say. Okay, I think this is the last one. Is a crash? Okay, do I have to even read it? This is actually so short. Give me a chance to read this short one. This is easy. Is a cross-platform C++ library for network and low-level I/O programming that provides developers with a consistent asynchronous model using a modern C++ approach. Everybody feels they got this? Raise their hand. Okay, you probably got it. Okay, what is it? ASIO. Right, exactly. This is a beautiful job. And by the way, I don't think it's if this is a sample of the whole library and its documentation, it's no surprise that it's very successful. So I think that I can get a sense oftentimes of the quality of a library from the very first sentence of the documentation. Okay, so I'm going to conjure up a new library, and I'm going to call it RingView. There's a proposal for, I think that just the name RingView, I think most of you should have in mind what it is, or at least what it is in your own mind, what a RingView class would be. I'm going to presume that. I don't see too many people looking with puzzled looks, but in any case, there is such a component being proposed for the standard library. They call it, they call it RingSpan, but in any case, the first sentence from that proposal is, this proposal introduces a ring to the standard library operating on a span named RingSpan. The RingSpan offers similar facilities to STDQ with an additional feature of storing the elements in a contiguous memory of being of a fixed size. Well, I have a couple of problems with this. First, it's tautological. It defines RingSpan in terms of the noun ring, and that's very odd to me. I'm not sure whether it could be a mathematical ring. It could be like a wedding ring. So I don't think that adds much. It also presumes an underlying continuous memory container, which is not what I expect to see at all. Now, I'm already criticizing the proposal. I've only read the first sentence. It goes on in this vein for 14 pages. That's another thing that I'm not crazy about. I'm not going to display it here. I don't think it's necessary unless you guys like to really enjoy reading standards proposals. But I just use that for reference because this RingView class that we're going to make and describe here is does the same thing or does a similar function. So here's the sentence that I made up. A RingView is an adapter which provides functions for first in, first out access to existing storage. Everybody okay with that? Or somebody want to do a better job? Oh, come on. I had to do it like 5 times. Go ahead.
Maybe replace the word functions with something. Functions like C++ functions or functionality or like facility.
Well, I'm referring to C++ functions. Excuse me?
That was not obvious.
Okay.
Eliminate which provides function just is an adapter for first in, first out access to existing storage.
Eliminate what provides?
The ring view is an adapter for first in, first out access to existing
Okay,
storage.
yeah, that would fly. That would be okay. That would probably be a minor improvement. As I say, this is the 5th attempt that I actually did this. And the first one was twice as long. This is extremely common, but it's very helpful to clarify your own thoughts. Okay, and so once I got that point, next thing I do is I'd start to write some code. I'm not really going big on specifications and all this yada yada. I mean, if you have to do it, maybe it's useful, and maybe in something really complicated it's useful, but the very first sentence to me gives, at least in my mind, and I think in the audience that I'm referring to, a fairly good idea what we're talking about. So I make a little demo here, I make a little example, I include my header, and I define some storage, which is 42 characters long. And then I construct a ring view, which has an iterator to the beginning of the storage, an iterator to the end of the storage. And I'm already thinking, or it should be fairly obvious, I defined a function called push, which appends characters. I defined a function called pop, which retrieves characters. And I have some checking in there to make sure that I don't push more than 42 characters in this case, and I don't retrieve more characters than have been pushed in. So I think that just about anybody in this room would consider this a pretty trivial and self-explanatory example. And I did include comments in here because I know I'm going to be including in the documentation, and it's frankly just easier to put the comments right here next to the code than it is to put it in some narrative apart and refer to it. So I'm already thinking about how this thing's going to be documented. Everybody, anybody have any corrections to this particular piece of code?
It would be nice to see what actually was displayed.
Yeah, this is the code. The documentation will show the output. We're not there yet, right? I'm just showing you what I wrote so far. I haven't written any documentation yet. You're already ahead of me. Yes, Peter?
Unit test, you would actually show what the expected result were in code directly.
Yeah, you would. And I haven't written a test. But if I get around to writing a test, I'll keep that in mind.
Start with the test up front.
Well, that's an interesting question. This is an example. It's really meant to expose, and it has a didactic purpose. It does test the code, but it's really not the purpose of this little module here. So I think I do make a distinction between writing the tests to test things and writing these little examples to illustrate your code. There is some overlap, but I think trying to include the facility of test in explanatory example overloads the example with too much.
I object.
Okay, your objection is noted. We like people who object and are willing to accept the fact that it's noted so we can move on. Okay, and so now, since I'm really hot to write my code, and I woke up last night thinking about it, and here's the code that I wrote for this. I'm going to confess this was not the first shot. I did have to run it a few times to make it work. So I import the iterator headers. I import the standard exception header. We know in our example it did throw an exception if there was a problem. I included assert, which I see now I don't use. And I include a header utility, which includes the description of the forward iterator type. Sure. Yes?
You have to include from tick. Why you have to comment that this is a tick library?
I am. I'm going to talk to, okay. Well, I'm going to explain it to you now. You're probably correct. Well, how should I say? Actually not, because if I'm including this, that would be some other documentation would explain what that is. But maybe it would be helpful. But I'm going to include it here, the explanation verbally, and just accept that somebody might think that they would like to see it in writing. So the first line I have here is the class name, and it takes a parameter of which I've denoted by an I. That parameter is an iterator. And we see a little bit farther down, we're constructing a ring view with a pair of iterators, clearly to the beginning and the end of the storage which we've already allocated. Now, at the very top of this, I have this thing that you might not be familiar with. It says tick trait check, and then it says is forward iterator. This is a type trait which will stop the compiler, throw away which will invoke a compiler error if the parameter we pass to this ring view is not a forward iterator. It's one of your users could easily say, oh, I just passed the storage, I say ring view vector. That's not what this accepts. C++, as things stand today, does not have the ability to check the features of a template parameter. And
what version of C++ are you talking about?
What?
What version of C++?
Well, now we're getting into the weeds. For the sake of the argument right now, if it depends which compiler which C++ version, etc. Up until this point, up until very recently, I can put it that way, there really was no natural way of checking these parameters. There was the Boost concept checking library, which even though it's been around for 15 years or maybe less, was hardly ever used. I don't think I ever saw it used. And with C++ 11, we now have the ability to implement the checking of type parameters. And this library, which has been submitted to the Boost library incubator, it's written by Paul Fultz, basically permits one to include this macro or macros like it and verify that a type parameter fulfills the requirements that we need to make this ring view work. So what this is basically it checks this parameter I to make sure that it's a valid iterator. That's what it does. Now, coming down the pike, and everybody's got a lot to say about this, as a practical matter, I have never seen anybody's code but my own actually check the parameter type. I'm sure there's some out there. Bjarne has made a big deal and whole talks about how you should be using concepts, which is what this is about. But currently, at least when he made that talk, the only way to do that was to use GCC compiler version such and such with the requires clause.
We have static assert in the language since C++ 11. We have corresponding traits, and with static asserts and whatever.
Right, and this library uses, this tick library uses those facility to provide an easy way of specifying.
So you want your code to compile with C++ 03. That's
Excuse?
why I was asking.
Oh, this particular library would require C++ 11 or later. And if you wanted to run this on C++ earlier than that, you just have to comment out that statement and hold your breath. Because typically speaking, libraries did not check parameters. Now they can. Still, the syntax is not real natural. The people that made the syntax think it's natural. I don't think it's particularly natural. This gentleman's made a library which makes it pretty natural, and I found it to be useful for this context. But what we're talking about here is the documentation. And this tells me right away, if I want to put this in to make sure this is used properly, then the documentation is also going to have to specify that the parameter for this ring view better be a forward iterator. So in this sense, we're keeping the two in sync. And that's kind of the rest of this is pretty straightforward, as you'd expect. It's got the functions listed. There's only a few. For purposes of illustration, and it's actually kind of convenient, I put the public interface to this type at the top and all the private stuff below. I didn't include any of the implementation stuff. I want to emphasize, it's my belief that it's helpful if we make a clear distinction between the user interface and the implementation. And by separating the public API from the implementation, in this particular example, it's my way of, of emphasizing that point. I think that when we create documentation, one of the problems is we put too much in there. I think that we should make a clear distinction between the user of this class and the person who's going to maintain it or whatever. The person who's going to maintain it or make it faster or find a bug, he's going to be looking at the code anyway. All the information that really specifies the details of how it's implemented can be easily found there. They can be commented there. The person who's using the class doesn't need, and frankly doesn't care at his level about those aspects. So I've tried to structure this in such a way that it emphasizes that distinction between the user interface and the other. So now's a good. Anybody have any questions? I'm hoping that this should look pretty familiar. Okay. Oh, and by the way, the class is a pretty cool little class, if I may say so myself. I needed this facility a bunch of times. There's a ton of them on GitHub. There's the standards proposal. They all look more complicated to me than this. Huh? But anyway, that's an aside. So here's what the documentation for this thing should look like. It should have an introduction, a purpose of the library, and we boil it down to a sentence, an even shorter sentence than I proposed. A couple, one or two or whatever motivating examples. This is the very simple component we're making. One example is plenty to illustrate how to use it. And then we'll have some notes, and then we'll have kind of weird stuff like, well, I'm not sure, stuff that doesn't fit anywhere else. Huh? And sometimes you have, well, I don't know. You might refer to the standards proposal in there or whatever. But as things go on, as a practical matter, you'll end up with something that doesn't fit anywhere. Well, that's where it fits. Then there's a section, that rationale. I'm not sure. I first saw this in Boost libraries. I'd never seen it before. And this actually is I find it to be very useful. As I'm coding, I discover little quirks that I decide to do something in a particular way because I discovered something like this doesn't work on that machine. Or, whoa, if I do that, it creates another problem. And then I just put that list of gotchas, I just put in this section called rationale, and I just number them. This thing, returns an R value. Well, actually, that's too obvious to even put there. But it turns out you have some miscellaneous stuff, some reasons that you did something, so that 5 months later, some guy comes and tells you, "Oh, you should have done that." Of course, that's a drive-by review. He's just spitballing you because he hasn't even looked at it. But now you have a reason why you did it that way. It's very helpful, and it keeps you from doing the thing again and again. It's also simple to do. And then we have, at this point, we have the reference section. Reference section is going to be pretty simple because it's almost like a form-filling exercise at this point. So let's see. It consists of 4 parts. Most documents most types and whatever won't have all 4. But one type is a concept. I call it type requirements. I believe the word concepts has been unfortunately very misleading, and we've been suffering from it for 20 years. Basically, it's every type that we use, every parameter type that we use needs a description of what that parameter type has to do in order to be useful in the context of our ring view. It turns out we almost never have to write such a page because those type requirements are all grouped into names in the standards documentation. We've got default constructible, we have move assignable, we have forward iterator, we have a sequence, we have et cetera, et cetera. So most of the time, those pages don't even have to be written. But it is useful to refer to them, and in the documentation, I will often find say the ring buffer requires a forward iterator. I won't include the concept page there, but I will have a link to the SGI document or something like that includes that. So at this point, we've only got one type. We've got no concept we're defining. We don't have any free functions being defined, and we're not having any meta functions. So our case is going to be, my example case isn't really rich enough to describe all the problems we could have. But it doesn't matter. I'm going to keep going here. The standards document, kind of to my surprise, actually describes how to describe stuff. Unfortunately, it's not very well described. So you can look at it. One thing that is interesting about it is it makes a special point of saying that when we're talking about a class, that we should describe things in terms of valid expressions as opposed to class members. And they say that specifically here. That always struck me as kind of odd. And actually, I became used to it, and I see the merit in it, I see the necessity of it. And I think that actually what the custom is today is that if we describe a concept, we describe valid expressions, and if we describe a class, we describe class members. I think we would be better off today if we used the valid expression method for describing class behavior as well as concepts. Later what can I do for you, Peter?
I would like to comment, the standard is never intended as a tutorial on how to use a feature.
It's a good thing, too. They were successful.
And it also opens to plenty of possible implementations of a library feature, which when you write your own library, you just have one implementation.
Well, the standard touched upon, I forget, they talk about method of exposition. I would probably argue that that's outside the scope of the standard. But anyway, they did have that little paragraph in there that I thought that was interesting. And another document, which is, to me, I'm going to call it to me, it's the Bible of how to do this. This is written in the late 90s, and it's got SGI, Silicon Graphics logo on it. I'm guessing it was written by Alexander Stepanov, but I could be wrong. It's unfortunate they don't have an author. And they describe here that this is the best, most succinct description of how these three different components should be formatted and what information they can include. He describes, I'm not going to go through it in detail here, but because you can look it up yourself. But when after this, next time you have this problem, go here. And this is where you'll find the real explanation. It talks about how to use, it talks about first concepts and how they're used, how to describe them, valid expressions. Then he describes another page, which is a type page. He gives examples for that. It has all the sections, and then a function page. This is really in a nutshell. The rest I'm going to talk about is really just examples of this. This is the thing you have to get to know when you're lost. And here in the SGI documentation, here's some sample pages. This is what a forward iterator looks like. It has a short description. It's pretty good. Excuse me. It has another interesting thing, which is a refinement of. A forward iterator is everything an input iterator is, plus a couple of other things. So there's an inheritance relationship going on here. So in the forward iterator, they don't describe all the stuff that it does. They just describe that what the forward iterator adds to the input iterator. So you'll find that these things are incredibly short. They have a little thing with notation, valid expressions. These two tables, I just consolidate them into one because it saves space. And that's pretty much it. And they describe as examples a couple of real classes that model this concept as described. We're going to actually use this forward iterator. Our documentation is going to just point to this so that when a person needs to know what kind of parameter he can put into a ring view, he's got it right here. I didn't have to write a word. I just had to put in a link.
Question?
Sure.
How do you think it helps the content that he specified the audience at the very beginning? I don't know if you saw that, but he specified a pretty sophisticated audience. I think I'm having a hard time following sometimes because I'm confounding audience. I'm thinking of a regular C++ developer that may not be sophisticated. I think this assumes a general familiarity with C++, especially with templates. I'm just wondering, how do you think that helps the document?
Well, why? Let me ask the question back. See if I got it right. What part are we looking at? It assumes a general familiarity of C++, especially with C++ templates.
Yes.
Okay. Additionally, you should read Introduction to the Standard Template Library before proceeding. I think that's actually, I don't know if it belongs in this part, but I think it's an accurate rendition. I think to use C++ templates, the ring view is a template, I think you should have general familiarity with C++ and templates at this point. At the time he wrote this, I think it was a very arcane and unusual skill. But I think today, most programmers should be using the standard template library. It's all templates, so they should have some familiarity with templates. They should have familiarity with template parameters and kind of a general idea what happens when you put the wrong kind of parameter into something. So I would say I disagree with you on that one. I think that this is appropriate and I don't know if it belongs in this document, but I think that it's true as it applies to this document.
I guess I was just asking in general, is it nice to say who the audience is? I guess that was my general question.
Right.
Do you think that helped the document that he said this is intended to? And do you think in future, anybody who wants to write content should say, this is the audience I have in mind?
I have to say I hadn't thought about that, to tell you the truth. I do believe that it's extremely useful when you write any document that you have a clear idea who the audience is. That's no question. Whether you have to explicitly state it or not, I think when we're talking about something like this, I think there's people pretty much going to generally agree. It wouldn't hurt to put it in. Maybe it's just a little verbosity you don't need. But I think the more interesting point that you raise is that you have to, at least when we're doing this, and I'm talking about a ring view data type that takes an input iterator, or excuse me, a forward iterator is a parameter, I think that very clearly defines the audience requirements. And I can write to that audience. So I feel okay about that. But if I were going to write a user manual, I would have a whole different way of looking at it. So I don't know if your question really wasn't a question, and my answer really wasn't an answer. But anyway, we had an interesting exchange. Okay, there's a forward iterator. Here's a class that has two template parameters. I picked this one because it's actually very similar to the ring view. It has a similar set of functions. I'm not going to go into this because I don't want to run out of time. It's pretty straightforward. Here's a function, documentation of function. I'm hardly even going to touch that because I don't think there's much disagreement about that. Yeah, Jens?
I think it would be much better if you, in just of the very old SGI STL documentation, so these Reference.com, which also has documentation on the iterator library.
It does, and I actually have a pointer to that. I'm not going to do that because it takes more time. But I find the old SGI documentation a better explanation of how to do it. I think that the CP reference is very, very good. It's quite good, and I use it all the time. But for purposes of the exposition today, and I also believe if one wants a model to help you write, this C++ reference documentation is not quite so regular as the old SGI. And the SGI one, if you want to, I think, learn how they did it, I think it's a good place to start. You'll be looking at CPP reference anyway. But I think that the fact that something is old doesn't really, in this case, diminish its value. And there's other situations for that. I'm 69 years old, so you're not gonna convince me of that. So I'm not convinced on that. So let's suppose. So now applying these principles, I've got my. Let's start building the documentation for my ring view. Well, I got my name there, copyright. Introduction. Here's the sentence. The first sentence we wrote down. Ring view is an adapter which provides functions for the first in, first out access to existing storage. It doesn't need anything else. As a matter of fact, as you guys reminded me, could actually use a little less. I'm sort of tempted to add something, but every time I do, I'm thinking it's not really adding anything. Then I have a tutorial, which basically is just my example. And there's one sentence there that says, produces the following output. And there's the output. This is, okay, granted, this is a little simpler than what you're going to run into. But it illustrates the value of restraining yourself from adding something just because you think you're expected to. In this particular case, I don't think adding anything would add anything. So we've already making a lot of progress here. Huh? We're like almost to lunch now. Notes, here I put the stuff that didn't fit anywhere else. Like it's similar to an STDQ and how it differs from that, and yada, yada. Maybe I probably put in more than I should have here. If you've worked with Q before, it basically tells you the API is going to be very similar. If you think this way, and a lot of us do, you're going to say, oh, it's just like the STDQ, except instead of allocating the elements, we have all the elements pre-allocated, so we don't need an allocator. We can have it on the stack. Oh, voila. It's going to be the same thing. It's just going to be a lot faster with no overhead. Or I can use it in embedded systems. That kind of information might be useful to put in there. Some embedded systems don't like using the heat. And on the other hand, if I've got a queue, I would be done. I'd be fine here. And so, or if I had a program that used the STDQ and then we want to port it to an embedded system, oh, well maybe just we can see right here with just a little tweak, we could get the effect without having to turn our whole system inside out. Here I put in the rationale, the comments that I had about the fact that this is part of the proposal for, or similar to a proposal for the standards committee. So there's not much to that. And here I have the type. This is pretty much taken from the SGI example for a type. It starts out with the function signature and describes the type requirements or the concepts that type requirement is required to support the forward iterator. And that matches up with this construct inside our code, which is from the tick library, which says is forward iterator, and which will fail to compile if I, in fact, does not meet that requirement. It's kind of a subtle point, but it saves gobs of time. We don't even really have to add anything to our documentation here because since the forward iterator is already defined by the standard, we can just suck it into our own document. Somebody can look it up somewhere else. We're done. That's that much we don't have to write. We don't have to describe what I is because it's done for. We leveraged on the free stuff. So, also, I wrote the ring view. I was careful not to define a destructor or my own version of the copy or whatever, because following the rule of 0, if I don't define any of those, they're automatically defined by the compiler. So more free stuff. The minute I were to put in my own destructor there, ooh, now I have to do more work. More work doesn't pay. And furthermore, I get a significant part of my documentation done, because once I know that the default copy assignment and move assignment and all of that stuff is implemented automatically by C++, that's another thing I don't have to document. All I have to do is refer to the concepts as described in the standards manual. So I cut my work a huge amount by, now somebody's going to come along and make my thing a little fancier by putting in a destructor which keeps count of something. Oh no, now he created a lot more work for us and more opportunities for mistakes. So I have the documentation when I'm writing the code. So and here's the SGI way of describing something with notation, associated types. One type that we have in here is the value type. We just forward that to the value type of the iterator. I believe that other cases they have a type for the value type. I don't know. I did it this way. Every iterator has a value type. I said we're going to make the value type of this construct the same. So we get that for free. And then all we need to do is really describe the operations that are supported here. And this is all they are. Now I had to horse around with this a little bit to get the R value thing right and whatever. And then I also included a link here into my source code. Let's see if that still works. No, that would be too much to expect. So before I started mucking with it, that worked. But normally it does work. And then here's all the little extra stuff that doesn't fit anywhere else. For functions, I have no free functions in this library, so there's nothing to describe and reference it. So that's the document for our ring view. It's been sort of mechanical to actually produce it. But let me tell you, mechanical is much better than getting stuck and having to try to use your brain on something that is really uninteresting. So we can keep moving forward on this. If we had more types, we'd be doing the same thing. Be kind of straightforward. If the only thing that might be different if we had more types is our motivating example might use a couple of types to see how they would work in combination. But other than that, it wouldn't change all that much. So I think, how much time have I got? 8 minutes. Were you falling asleep or you were just engrossed in the thing? No, okay. So my documentation system also produces the same thing in PDF, which is kind of nice, but it's just strictly speaking, it's a freebie. Okay, I'm going to recap here. The purpose of the documentation is to help the users. That maintainers, they'll use it a little bit, but their real help is inside the code itself. The code and the documentation should reflect the same intention, and we're trying to address the public API. If you use a tool which generates for every single function a little bit of documentation, I think it's a bad idea. Most functions are just listed in the type, and most of them are fairly simple that just the table is sufficient. If a little bit's necessary or there's some extra information, you can put it there. I don't think you need pages and pages with one function header per page. It just takes up a lot of time, it's tedious, and it doesn't add anything. As a matter of fact, it detracts anything because it's intimidating. It keeps people from finding what they need. Okay, how do we build this? We do it in conjunction with a code. We do it to keep the program from turning into a miscellaneous bag of tricks. And a miscellaneous bag of tricks is something that's hard to document. And when we do that, because people drive by and they drop a suggestion into your box, or somebody comes up with a great idea, it sounds great, and somebody codes it, and then when you come back and try and document it, you find it wasn't a bad idea, but now it's too late to take it out. No, this is better. Somebody comes in with a little thing, we update the document, and whoa, wait a minute, this doesn't work. We see it right away. So this helps fight scope creep. This helps keep you from being everybody's slave. It helps you to keep moving forward while everybody is actually trying to, quote, help you out by giving you more dumb ideas. So if you have to do this documentation part, and it's not that very hard when you do it this way, you'll find out right away that something is a bad idea. And you'll save tons of time and not waste so much time on bad ideas. So here's the general way it looks: introduction, examples, notes, rationale, and then a reference. Reference is a separate part, and that describes each one of the following. I don't have to beat this to death. We already did. What do we gain? Agreement on its purposes. Better conceptual integrity. We have a type or a document which describes something that hangs together and not the miscellaneous bag of tricks. It's just my slides that make me repeat that, but maybe it's a good thing to repeat. Tools. Tools don't create the document. We do. Tools can help, or they can make things worse. I'm going to pick out 3 tools which I think are the only ones I'm familiar with. Let me put it that way. Doxygen. The good part is that it keeps the reference documentation in sync with the comments. This is actually a huge feature. It's very helpful. People love it, and for a good reason. It is a good thing. The bad thing is there's no obvious way to create concept pages with it, or actually other pages. I've seen that people do it with macros or adding their own stuff or whatever. It becomes so much work to try and make Doxygen do what I want it to do. It just seemed more work than it was worth. The whole purpose for me was to do less work, and here I am. I felt I was arm wrestling with Doxygen all the time. Including narrative and examples, a lot of work. Generating alternative output formats like PDF or ebook or whatever also doesn't come free with that. Yes, Jens?
I think one of the big examples from Doxygen is with a little bit of work, you can get a really nice call graph for your group types and functions.
Well, maybe. I don't think it's worth the trade, but I don't really want to denigrate Doxygen so much because it is actually a masterwork. But I think what it really boils down to is paraphrasing the header files, and that's not really adding information. That's not adding the part that I'm missing here. It kind of gives me what I'm not needing, and it doesn't give me what I am needing. That's the way I see that. DocBook. DocBook is this XML thing. It's BoostBook is a variation of DocBook. One great thing about DocBook is that it decouples the content from the formatting. So you really describe all your code and whatever using these XML tags. And then you can generate the output in the format that you want. Ebook, PDF, HTML, single page HTML. I really love it. It's really great. The bad part is editing XML is like a huge, it's like torture. It's terrible. So some people have come up with ways to do it, Emacs and whatever. In Boost, Eric Niebler wrote a component called QuickBook, which lets one take a text file and prepare it, and it will generate the XML for you. And that's been very popular within Boost. I'm guessing half or more of the documentation in Boost uses that component. My personal favorite is XML Mind. I've been trying to convince people to use this in Boost. I've had 0 success. Oh well. But basically, it's an editor for XML. And they have a free version, and there's an add-on which is for C++ documents like the SGI, derived from the SGI scheme. So basically, it lets me just create type page, create a concept page, and then just fill it out almost as if it were a form. And then from then I can generate PDF or whatever. Setting up the tool processing is kind of a pain, but even so, that's the one that I like. So I don't know if we have any time left. It says session is over. 45 seconds. One question. Yes.
We always say that the problem is that at some point the code will disagree with the documentation. Do you have any guidelines to keep both in line?
2. First is document less. Don't document implementation features in the user document, right? And I've said that you should have the implementation stuff in the code, and if you do that, then when you get a better implementation, well, the interface is the same, right? So there's less opportunity for discrepancy. So that's the overall piece of view I have on that. Document less. Don't generate something with everything in it. Generate something with just what just describes the API, and if you make changes in your code, it won't matter unless you really change the API. That'll help a lot.
I think there's a difference to make between documentation for actually the users of a library and documentation for people working on a library or a program.
Well, and I have made that distinction, and I think I've made an effort to make it a very obvious one, that this is for users of the library, for people maintaining a library. They just look at the code. They don't need documentation. Documentation is not, this documentation I'm talking about here is not that helpful to them.
Can I ask a question to the audience before everybody leaves? How many of us here share the view that UserDoc can be used as an effective tool for quality control, for ensuring test coverage for the code that we write? Maybe just a show of hands. Very few. All right, thanks.
Interesting question. I hadn't thought of it myself.
It's been very useful for myself, but I wonder how to get this idea across to my team members, to my company, and maybe we can have a talk.
Well, I think,
one-on-one.
in the context of what I said, I think that it's kind of interesting where that would fit in.
Yes.
It didn't occur to me.
Yes.
Thank you for showing up.